Hey, what's up? It's Jake from Nimbus DevOps, and I'm here today to talk to you about persisting data on disk. I've got two examples to go through, so I'm going to go through them kind of quick, and hopefully you get what you're picking up what I'm putting down. So we saw how to persist data in three different formats. Persisting data means the data is written to a non-volatile storage, like a hard drive. It's not deleted when the process is ending or whatever. So we're going to look at two examples, Pickle and Shelve, which as a short example will involve accessing a database using SQL Alchemy, which is probably the most widely adopted ORM library in the Python ecosystem. So let's talk about serializing data with Pickle. So the Pickle module from the Python standard library offers tools to convert Python objects into byte streams and vice versa. Even though there's a partial overlap in the API that Pickle and JSON expose, the two are quite different. JSON is a text format. It's very human readable, language independent, supports only a restricted subset of Python data types, whereas the Pickle module is not human readable. It translates to bytes and is Python specific, but it does support a large number of data types. Besides that, the differences between Pickle and JSON, there's also some security concerns you should be aware of. Unpickling erroneous and malicious data from an untrusted source can be dangerous. So if you decide to adopt it, you need to be extra careful. Having said that, let's see it in action. So we're going to import Pickle, and then from data class, we're going to import data class, or I'm sorry, data classes, import data class. And then all we're going to do, decorator at data class, and then we'll make a class person, and we'll say first underscore name is a string, last underscore name is a string. ID is going to be an int, and we'll make a function define greet, and it will be take self, and we'll just say print f hi I am, and then inside of it self dot first underscore name, self dot last underscore name. Let's see, what else do we want to do? We'll leave that. I'll make a new line, and then let's do f and my ID is self.id. There we go. Can I line this up any better? I'll just do that. That'll work. Okay. So now we need people, right? So let's do people, and then we'll make a nice little sequence here, and we'll say person Obi-Wan Kenobi, and his ID is 123. Okay, that'll work. And then the second object, we will call the person class and say Anakin Skywalker, and his ID will be 456. I don't want this to be a string. Oh, because this one's not closed. Okay, there we go. Now that looks right. Okay, cool. So I now have person, and I have a second person. So now what we want to do is save the data in a binary format to a file. Okay, so this is for our persistence. So with open data.pickle, we want to write with bytes as stream, and we'll say peeps equals pickle dot load whatever is in the stream. And then once that's done, we can say for person and peeps greet, person dot greet. Okay, so in this example, we create a person class using the data class decorator, which we saw before, and we wrote it this way to show you how easy it is for Pickle to deal with it, and you don't need to do anything, and you can just do this and it does everything for you. So we'll create a list of instances and save it to a file. In order to do so, we use pickle.dump, which I did load. Did I do the dump? I didn't do dump, did I? I only did the load. I forgot to do that. Okay, let's say with open data.pickle, and let's do a write byte as a stream, and then we'll do pickle.dump people and stream. Yeah, we're going to need that for this to work. Okay, there we go. All right. Um, so the pickle.dump part will feed the content to be pickled and then stream to which we want to write. So immediately after that, we read from the same file using pickle.load to convert the entire content of the stream back into Python objects and make sure the objects have been converted correctly. We call the greet method on both of them. And the results should look something like, let me make sure I save this, Python pickler. Unsupported IO operation read. Line 25, pickle load data.pickle as stream, pickle load stream. Does that look right? Person.greet. Did I not have a, where's my greet? Define greet self. Okay. Let me just double check all my code here. All right, so data class decorator class is person, first name string, last name string, ID int. That looks fine. And then define greet self print. Hi, I'm Obi-Wan Kenobi, and my ID is whatever the ID is. We have some people. We use person to set first name, last name, and an ID, and that looks fine. And then we're going to save the data in binary format, and we're going to say with open data.pickle write byte as stream, and then pickle.dump people stream. And then after that, let me even put a note in here. Let's sort of comment. We're going to load data from a file. So with open data.pickle. Oh, hi, how's it going? We need to read bytes. All right, let's try this. There we go. Hi, I am Obi-Wan Kenobi, and my ID is 123. Hi, I am Anakin Skywalker, and my ID is 456. So that works. So in this example, that works out pretty well. The pickle module allows you to convert to and from byte objects by means of dumps and loads. And the day-to-day applications Pickle usually used when you need to persist Python data that's not supposed to be exchanged with other apps. One example would be like a session manager in a Flask plugin where it pickles the session object before storing it in a Redis database. In practice, you're probably unlikely to have to deal with that library very often at all. Most of these libraries nowadays just do so much for you. It makes it a lot easier. So the other tool that you may use even less than Pickle is Shelve. So I said shelf in here, but it really should be shelve. Shelve. All right, so let's clear the screen. We'll close our pickler, and let's talk about shelf. So this is a persistent dictionary-like object. The values you save into shelf can be any objects you can pickle, so you're not restricted like you would be if you were using a database. It's interesting and useful, but the shelf module is really not really used that very often. But just so you can see it and you understand what it is, we'll do one quick coding thing. So let's import shelf, and then we'll say I have a class person, and we're going to define initialize, and then we want self, name, and ID. And then we'll say self.name is name and self.id equals ID. Pretty simple. So then what we'll do is we'll say with shelve dot open, and let's just say shelf one dot shelve, yeah, as DB, like a database. And now we make DB. So DB could be like OB1. This should be a string though. OB1. And that will be person OB1 and 123 for the ID. And we can do a DB for Annie and say person person, Anakin, yeah, Anakin, 456, yeah, the ID. And then another DB, we'll do a list, and in there, we'll just make this a list of 2, 3, 5, and then we'll have another DB for delete me, and that will be we will have to delete this one. I'll show you why in a sec. Yeah, let's go to, let's print. All right, so let's print a list, and we want the list of db.keys, just like that. So this should give you Annie, delete me, a list, ob1, etc., etc. All right, so now we need to delete db, and we want to delete me underscore me, so we can get it deleted. And then we're going to print the list again of db.keys, and we should see Annie, a list, ob, but delete me will be gone. And then we can also print this delete me in db, and it'll be false because it's not there. And then we should say print Annie in db, and that will be true because it is there. And then we'll say a list equals db, and then a underscore list, and we'll make an a underscore list dot append, and we'll add a 7 to that list. And then db a underscore list, let's go ahead and set that to a list, and then we can print db a underscore list. Yeah, and that should give us 2357. So apart from like the wiring and boilerplate around it, it's pretty much just like doing dictionaries, right? Like making dictionaries. So we create a simple person class, and then we open the shelf file with a context manager. And then we use the dictionary syntax to store 4 objects, 2 person instances, a list and a string. And if we print the keys, we get a list containing 4 keys we used. Immediately after printing it, we delete the aptly named delete me key value pair from the shelf. And then printing the keys again shows the deletion succeeded. And then we can test a couple of keys for membership. And finally, we append 7 to the list, and we can extract the list from the shelf, modify it, save it again, do whatever we want with it. So let's run it and see what happens. So Python shelf. Partially initialized module shelf has no attribute open, most likely due to a circular import. All right, so this was in line 8 with shelf.open, shelf1.shelve as db. So we go back to line 8 and look at this code, and we say with shelf.open, shelf1.shelve as db, which looks fine. And I don't see any issue with that. So let's walk through this. So my class, define, initialize, self name ID, self.name is name, self ID ID, with shelf.open, shelf1.shelve as db, which looks correct. db ob1 equals person ob1 123. Same thing for Anakin. And then we have a list 235, a db delete me, which is just set to a string, and then we print that out. And then we have the delete, which is fine, didn't even get there. And then at the bottom, I have a list, which is a list. We append it, set this to a new variable, and then we print the db for that. That looks fine. Has no attribute open. Partially initialized module. A circular import. Huh. I wonder why it's doing that. Pip install shelf. Let me Google this really quick. Okay, so maybe there's a reason I named this shelf when I was trying this earlier. You can't really name your Python file something the same as the module that you're importing, or else it has some weird circular reference. So if I run it now, it just says it can't open a file because there's no directory. So now it's trying to open something, and I can name this something else. So like if I did shelf like that, it says shelf.py, no such file or directory, with shelf.open. So that's why. Let me fix this. Okay, so I looked into this, and it looks like the code provided has a bug in it, and well, the code is fine, but it was fine like a long time ago. So this is why I go through and test this stuff. So for now, I wouldn't use Shelf only because there's a lot of reported bugs in this, and there seems to be some problems in it. So I can just end it here and tell you just use Pickle. There's a better way to do that anyway. So it's in the standard library, et cetera, et cetera. So anyways, that's what I would do. And if you want to dig more into that, then hey, feel free. But writing to the persistent disk to a file isn't really a huge challenge. There's so many ways we've done it so far, so not a huge deal. So anyways, I'm gonna stop it here, and I'll report this bug back to the author and then let them know. And in the meantime, you can go ahead and stop here and go grab yourself a drink, and we'll come back and start looking at saving data to a database.